Hello, can somebody confirm you can hear me?
Yes.
Thank you. All right, my computer's going to be a little slow because I'm still processing the reading from the lecture, about 86% done. So just bear with me. Oh, that's not what I want. Let's close that one down. Before we begin, are there any questions? Can you see the screen? It should be. All right. So today is April 17th, and we're supposed to be discussing Lab 3 on microscope basics. Hopefully you read the textbook chapter through the end of the section on compound light microscopy before you begin Lab 3. If you haven't, before you begin, you should read that part of the textbook. Any questions about Lab 3? All right. Remember to turn in your request for an infectious disease project. You need to get it approved by me. Sometimes, about a third of the students, I'm either narrowing the topic or I am telling them it's not an infectious disease. So it does need to be approved by me. And then also, there's a number of students who are requesting a topic that has been taken already, like tuberculosis. Everybody likes tuberculosis. So that one's pretty much taken. Um, Ebola, that one's taken. I think HIV-1 is taken, although HIV-2 is not taken. So there's a lot of topics that have now been taken. So if you're requesting a topic now, please request a topic and at least one other backup because a lot of topics have been taken. It looks like the lecture file just got made. Let me check on that. Yep, that's right. So my computer will start working better now. Let me rename this while I'm here. And that'll ease my transition when I make that public. All right, let's go out of here and come back to here. Oh, another thing I need to tell you about is vote on the whether the labs be graded one time or two times. Put that in the student discussion. This is a region for you guys to discuss different topics about the class. You can request forming a study group with this student discussion. But in the first 2 weeks, meaning up until this Saturday, you can vote on whether you want the class labs to be graded one time or two times. And then we'll go as the class votes. All right, let's see. Let's go to the lab module 3. Lab module 3, microscope basics. Microscopes are expensive and easily damaged. As such, there are certain protocols for their care and use. You should follow these instructions carefully, even though you're not going to be handling a real microscope, because everything we do will be done online. You do need to know how to properly handle a microscope because you've taken microbiology. And so you will be held accountable for that in the quizzes and in the labs for this lab. Read the lab module and the class textbook on chapter 3 through the end of the section, Compound Light Microscopy. There's always some reading for the lab. Some video clips. There's also an online exercise using a virtual laboratory where you will use a virtual microscope, meaning you'll use a program that'll simulate using a microscope online. The learning objectives, you're not going to be physically using a microscope. However, upon completion of this lab, students should be able to, one, locate and name the parts of compound light microscope along with describing their functions. 2, calculate the total magnification for each objective lens used. 3, know the guidelines for focusing specimens with different objectives. We have 4 objectives on our compound light microscopes. The scanning objective, also called the 4X objective, the low power objective, also called the 10X objective, the high power objective, also called the 40X objective, and the oil immersion lens, also called the 100X lens. I tend to not use these terms because the low power and the high power tend to get students confused. I will call them 4X, 10X, 40X, and then 100X. Although I do occasionally call the oil immersion lens the 100X and vice versa. And then the 4X occasionally the scanning lens and vice versa. Estimate the size of a specimen when seen with a different magnification power, meaning a different lens, be able to estimate the size of the specimen. And then next, understand the rules for proper microscope care. You do need to know how to take care of a microscope, even though you're not going to be using a microscope. And then lastly, define the terms assigned with microscopy as described in this module and in the textbook. So for the compound microscope, you must memorize the names and the functions of these parts of the microscope. One, this is called the ocular lens or the eyepieces, and they do magnify the specimen that's viewed. Depending on what the power of the lens is, they're usually 10x magnification or 20x. The best microscopes have 20x. All of our microscopes in the microbiology lab, and as far as I know, all the microscopes at Clark College have only 10x magnification in the ocular lens. It's called the compound microscope because it has 2 lenses that magnify, the ocular lens and the objective lens. 2 is the objective lens, and it is on a rotating nose piece right here and here. And that way you can rotate which lens you want to use. You can use the 4X lens, which looks shown there. The 10X lens would be this one there. The 40X lens is not seen. It's either here or there. I'm not sure where. It's being hidden by another lens. And then the 100X lens is right there. Any question about that? Now it's called the compound light microscope because we have 2 lenses that magnify, the objective lens and then the ocular lens. 3 is the stage. That's what you put the slide on. That's what moves up and down to focus on the specimen. The stage clip is 4, shown here, and that allows you to move the specimen under the field of view of your objective lens. So the clip can move this way and then that way to make your object, the specimen, move under the lens. Not seeing 5. Let me scroll down. 5. This is the stage controls, which adjust where the clip moves, and one of them moves the stage this way and that way, and the other one moves the stage this way and that way. 6 is the iris diaphragm. It is a shutter that can open and close. The amount of the condenser. The condenser 7 brings up a cone of light onto the slide, and you want that cone of light to be about the same size as the field of view of your objective lens. And so what that means is when you're first using the microscope, staying at low power, the 4X lens, you want that iris diaphragm to be fairly open, not open all the way, but almost all the way. And as you go up in power with the objective lens, you need to start shutting that iris diaphragm down. So the iris diaphragm and the condenser are always together. In this microscope, it's showing you the iris diaphragm above the condenser, but on some microscopes, the iris diaphragm is below the condenser. What it is, like I said, the iris diaphragm simply is a shutter that opens and closes the cone of light coming up onto the slide, and then the condenser forms that cone of light, which just brings a cone of light up to the specimen. It does not magnify the specimen. Any question about 6 or 7, the condenser or the iris diaphragm? All right, 8 is the coarse focusing knob, the big knob here, and it moves the stage greatly up and down. A 9 is the fine focusing. It finely focuses the stage, moving the stage only a little bit, either up or down. 10, that's the light switch, which obviously when the microscope is not in use should be turned off. And when you want the light to be shining through the microscope to view the microscope, you turn the light switch on. 11 is called the rheostat. It adjusts how bright the light is. And apparently they don't use the rheostat name in Australia. The person who wrote up the lab module, I think he called it the light intensity dial. Yep, light intensity dial, which controls how bright or how dim the lamp is. And then 12 is the lamp. That's the light source itself. Any question about any of those parts of the microscope? So you must know these parts of the microscope, what they do. You should also know this table. It has the name of the lens, which I don't use too much, the power of the lens, and this is the name I use, the 4x lens, the 10x lens, the 40x lens, the 100x lens. This is the magnification of the objective lens. The total magnification of the image will be the power of the objective lens times the power of the ocular lens. And as you can see, this table is set up for our microscopes, and all of the ocular lenses are 10x in magnification for all of the microscopes in microbiology, and probably for all the microscopes at Clark as well. So the total magnification for the 4x objective lens will be 40x. The total magnification for the 10x objective lens will be 100x. For the 40x lens, 400x, and the 100x lens, 1000x. Total magnification, just the magnification of the ocular lens times the magnification of the objective lens. The depth of field is how deep of the field you can see under the objective lens. With the 4x objective lens, the field is deep, and you might be able to see both the top of the object and the bottom of the object because the depth of field is deep. Get a piece of paper here. For the low power or the 10x lens, the depth of field is moderate. It would be not the entire object, but maybe half of the object. From the top down to about half of the object would be seen clearly in the microscope. The lower half of the object would not be seen clearly, if at all, under the objective lens. The 40x lens has a smaller depth of field. So instead of being maybe half of the object, maybe about fourth of the object, so you can see from the top of the object down to about fourth of the object. So the depth of field is smaller. And then for the oil immersion lens, the 100x objective, the depth of field is very narrow. Essentially what you're seeing is one plane of the object. So one plane through the object is all you can focus on. Any other regions of the object you would not see clearly, if at all. So the depth of field is narrowest with the 100x lens and is deepest with the 4x lens. The field of view follows something similar. The field of view is how much of the slide you can see, pretend this is a slide, how much of this slide you can see under the objective lens. With the 4x objective lens, the amount of field of view, or the amount of slide you're seeing under the specimen, will be fairly large. And as you go up in power with 10x, the field of view will reduce. With 40x, it will reduce further. And then with the 100x lens, the field of view will be essentially only a pinprick. So very small field of view with the 100x lens. Any question about any of that? Some comments on the different lenses. The 4x lens is the easiest to use because you see the largest field of view. You're most likely to see the specimen under the microscope. And it also has the deepest depth of field so that you can see the specimen from the top or the bottom. So the deepest field of view means that you're more likely to see the specimen. The 100x lens, on the other hand, is the hardest to use because you're seeing the smallest amount of the slide. And then you're also seeing the least depth of field. Essentially, you're seeing one plane of the object under the focus of the objective lens. Any question about any of that? All right. It's also noteworthy that when you view an image under the microscope, it is more than just magnified. It is also inverted and reversed. So for the letter E here, you look at it under the microscope, it will appear this way, magnified, but inverted and reversed. Any question about any of that? All right. The iris diaphragm can be opened or closed down to allow more or less light through the stage. And that way you can use it to increase the amount of light coming in or decrease it to reduce the amount of light coming in. More importantly, the iris diaphragm affects the contrast of the specimen against the background. So to get the best contrast between the specimen and the background of the slide, you need to have the iris diaphragm open to the correct amount. And that's usually about the size of the field of view that you can view under the objective lens. So with the iris diaphragm, when you have the 4x lens, you want the iris diaphragm to be fairly open. And as you go up in power, you need to start shutting down that iris diaphragm. Any question about any of that? All right, some tips for focusing. When you first use the microscope, start with this 4x lens because it's the easiest to use. You'll have the easiest time seeing your specimen and focusing in on it using the 4x lens. You should use the coarse focus adjustment knob to slowly raise the stage and bring the object into coarse focus. Then use the fine focus knob to bring the object perfectly into focus. Once you've started using the fine focus knob, you should never use the coarse focus knob, except when maybe you're using the 4x objective. The reason being is that our objective lenses are perifocal, meaning when one objective lens focuses in on a specimen and then you switch to another objective lens, it also should be focused on the specimen, meaning they're perifocal. And so once you've stopped using the coarse focus and you started using the fine focus lens, you should only use the fine focus lens. If ever you accidentally use the coarse focus lens, you should go back to using the coarse focus lens with the 4x lens to bring your specimen into fine focus before you go up in power for the objective lens. That's the easiest way to do it. And if you start using the coarse focus lens and you have the wrong objective in there, objective lens in there, you're just going to screw off the perifocal vision. And like I said, it's just easiest to start with the 4x lens and get the object in focus again. So all additional focusing, once you have it fine focus, should only use the fine focus adjustment knob. Coarse focus should only be used with the 4x lens. All right, so when it comes time to go up in power, meaning switch to another objective lens, the microscopes are parafocal, which means that they will stay in rough focus from one objective lens to another. So only the fine focus knob should be used. Before you switch from the 4x lens to the 10x lens, you should find your specimen and then move it into the center of your field of view before you switch to the next objective lens. The reason for that is, let's say your specimen is over here, and here's your field of view. I don't know if you guys can see this. I can't see it. Can you guys see this? Anyone? Hello?
Yes.
Okay. If you have your specimen over here and your field of view is here, when you go up in power, the field of view will shrink. And now our specimen is no longer in the field of view. So you want to move the specimen in the center of your field of view every time you go up in power to make sure that the specimen will be in the field of view. And then you repeat step 9 each time you move from one objective lens to the next higher powered objective lens. Meaning if you need to use fine focusing, use the fine focus knob to bring it into fine focus. And then before you switch it up to the next higher powered objective lens, make sure the object or specimen is inside the center of your field of view. Any questions about any of that? All right. The 100x lens or the oil immersion lens must use oil or its magnification will not be any better than the 40x lens. So if you're not using oil, you may as well use the 40x lens instead because it will be easier to work with and you won't get any higher magnification. The 100x lens requires the use of oil, which requires a slightly different use of the microscope. And why we're using oil is it has the same refractive index as glass, allowing more light to be gathered by the objective lens. This will increase the resolution and the clarity of the image. So we use oil, which I'll talk about later, but to reduce the refraction of light, it'll allow more light to get into the objective lens, increasing the resolution and clarity of the image. We'll talk about that in a future lesson. So how you do that is you take your 40x lens and you don't move it all the way out and bring the 100x lens into place. You move the 40x lens, let's make it like this. You move the 40x lens halfway out of place and the 100x lens halfway into place. That will allow you to get a drop of oil let's make this the drop of oil. To bring in the drop of oil and put a single drop of oil on the center of your specimen. And then you move the 100x lens over the oil, and that 100x lens will actually go through the oil, meaning the 100x lens is close enough to the slide that I can't do that with another one. I would pretend that's our drop of oil. That 100x lens will actually go through the drop of oil. Any question about any of that? And that will prevent there being any air between the slide and the objective lens, meaning there will be oil in between, allowing more light to come through. Any question about that? All right. Whenever you use oil, you must clean the oil off of the 100x objective lens with lens paper. Only use lens paper to clean the lenses. We use lens paper. I don't have any lens paper here, but we'll pretend this is lens paper instead of it actually is. This is not lens paper. It's a paper towel, but or a napkin. But we're going to pretend it's lens paper. Lens paper has the wood fibers in the paper removed. The wood fibers in paper will actually scratch the lens. And the objective lens is the most expensive part of the microscope. And so we don't want to scratch the lens and then damage the lens. So we only clean the microscope with lens paper, which has had the wood fibers removed from the paper. Any question about any of that? All right, you can read about troubleshooting. For activities, we're going to be doing activity 1, but it's going to be done online. You're not going to perform this activity with a microscope, but the table has already been filled in, and you will be expected to know the information contained in the table. And if you want, you can know the formula that we use to figure out how large a specimen is under the objective lens that we're using. So go through the procedure here. Normally we have the students in a real microbiology lab do the measurement for the field of view under each objective lens. And because you can't do that, we have the table filled in for you that the 4X lens has a field of view of 4.5 millimeters. That's 4,500 micrometers. The field of view of the 10X lens is 1.8 millimeters, or 1,800 micrometers. The field of view for the 40X lens is 0.45 millimeters. Note, I don't know if I have a ruler here or not. Note that 1 millimeter is the smallest unit of measurement on a ruler. And so the students were having to measure less than the smallest unit that the ruler can measure. Sometimes they got that wrong because they'd be guessing a little off. Looking to see if I have a ruler here. I might not. And then I might not be able to find it even if I have it. Anyways, the smallest unit of measure on a ruler is 1 millimeter. And then for the oil immersion lens, the 100x lens, the diameter of the field of view is 0.18 millimeters. Very small, and the students would have to estimate that, and we're giving it to you exactly. So you should know this table, what the field of view is for each of the objective lenses. And then this will help you estimate the size of a specimen. For example, if we're using the 10x lens, and the specimen takes up half of the field of view, what is the size of the specimen? Can anyone give it to me? Nobody wants to guess? The worst you're going to be is wrong. If you guess correctly, I'll give you an extra credit point. All right. Because the field of view is 1.8 millimeters, and the specimen takes up half of that field of view, the specimen will be 0.9 millimeters in size. Any question about any of that? So we can use this table to estimate the size of the specimen that you are viewing under the microscope. If you wanted to calculate it, we have a formula here. Where the heck is that?
Was it above the table?
Right above here. Yeah, there it is there. So what you
Oh,
do,
sorry, go
the
ahead.
diameter. Yeah, thank you. I just couldn't find it. I thought it was below the table. We get the diameter of the field of view of the objective we're using. So you get that from the table here. And then the diameter of the field of view of the 4x objective, and that would be 4.5 millimeters, times the magnification of the scanning objective, and that would be 4x, divided by the magnification of the objective we're using, so let's say 10x, and then that will give you the diameter of the field of view of the objective. So you can use this table to calculate these numbers, but we filled in the numbers for you in the table, and it's just easier to remember the field of view of the table for each objective. Doesn't matter if you know it in millimeters or micrometers. And then you can determine the size of the specimen if you know the size of the field of view under each objective lens. All right, online students are not going to be performing activity 2, observing prepared slides, but you will be doing a virtual exercise of this activity by completing the laboratory exercises at the end of this document. We expect that you will know and understand the material in this exercise. So read through the exercise. You'll be doing it on the virtual microscope, which is a program you'll run on your computer. For activity 3, we're not going to be making a wet mount, but online students will not be tested on this, but you should know how to make a wet mount. So if you've never made a wet mount, you should read through this because making a wet mount is something you do all the time in microbiology. So if you don't know how to make a wet mount, you should read through this. If you know how to make a wet mount, you can skip it. For activity 4, you're not going to be handling real microscopes, but you are expected to know how to correctly store a microscope. I thought I had an activity 4. I must have removed it. All right. So prior to storing your microscope, you should lower the stage, remove the slide and put it away appropriately. If there's oil on the slide, you should clean off the oil. You should also clean off the oil with lens paper on the 100x objective lens, and you should check the 40x lens to see if it got oil on it, meaning when you put oil for the 100x objective lens to use, if you then rotate the 40x lens through the slide, that 40x lens will be low enough to go through the oil and pick up oil on it. So you should check the 40x lens whenever you're using oil, and then you must remove the oil on the 100x lens. And if it's on the 40x lens, you must remove it as well. Otherwise, the oil will dry on the scope, and I still have that on. I thought I removed that. I had a medical procedure yesterday, and I noticed I still have the bracelet they gave on. gave me. Apparently I had two of them because I removed one of them. Ah, it ripped. Anyways, you must remove oil from both objectives if you get it on the 40x lens. You can just check to see if it's on the 40x lens and then remove it if it's not on the 40x lens. Put the 4x objective in place and lock it in place, meaning if you use the 100x lens last, it should be removed and then you switch the 4x lens so it's now over where the specimen used to be, meaning over the light source. You then should lower the intensity of the light to minimum and turn off the light with the on-off switch. You should wrap the cord neatly around the microscope. We don't do 7, at least in my class, because they don't have you adjusting the turret. And then you carry the microscope with two hands. One hand underneath the microscope to support the base, the other hand carrying the microscope. So keep the microscope in an upright position, and our microscopes are pretty heavy. Most people carry it with two hands anyways. And then place the microscope back in the same cupboard you got it from, in the same way you have it. So if this is a microscope, with this being the front of the microscope, this being the back of the microscope, you would put it in this way, meaning that the objective lens are facing backwards. Not objective lens, sorry, the ocular lens are facing backwards. The next statement is not important for an online course, but if you take the course online, proper microscope use and care is important, and you would get a penalty if you were not handling your microscope appropriately. All right, you should overview the microscopy terms. And then we have a laboratory exercise. We have a little video on general microscope focusing, another video on using oil on the microscope. So watch both of these videos. And then we have a practice your microscopy skills by using a virtual microscope. It is slow to download. So open it up. And let me go to the worksheet here. So right there on the worksheet gives you the links to view the video clips and then the link to use the virtual microscope. All right, takes a little while to download. Once it downloads, you can take a look at the guide, the learn, the explore, the test, the options. We're going to explore. It tells you right there what to do. And there's the slide box. Wherever there's a question mark, you need to click on that. And let's see what my question is. I think it's the hairs on the animal slide when viewing the spider leg. So take a look at the spider leg clip, that slide. I think I might ask you some questions about the plant slides. So if you look at the plant slide, you should look at the onion root slide. So let's look at that first. Use the coarse focusing knob to get it in coarse focus. That will adjust the stage, as you notice when moving this, and get it in coarse focus. It's a little too far, someplace around here. And then use the fine focus to get it in fine focus. You can adjust the light. Actually, it's fine now. We might adjust it later. Make sure it's in the center of your field of view. And then go up to the 10x lens. And there it's switched. And actually, it's pretty good focusing here. Now I'm looking for a specimen with I'm not seeing it. That might be it there though. So let's move that down about here. Then go to the 4x objective lens. Yep, I'm really close. It's right there. A cell going through mitosis is what I was looking at. And then let's use the fine focusing knob. Bring that in fine focus. Think about there. If you need to, you can adjust the light. Let's turn the light down a little bit. And now to get up to the 100x lens, you need to add oil. So this is telling you to add immersion oil. The question mark is the oil, and that will add the oil there. And now you have to finely focus. I might have to use the coarse focus if it's not better. That's probably pretty good. I don't see oh, there it is there. The cells going through mitosis. All right, any question about that? Remove the slide. Because we used oil, you got to use lens paper to clean the oil off of the lens. So there's cleaning the oil off the lens. Remember, lens paper is paper with no fibers in it, no wood fibers in it, so it doesn't scratch the lens. All right, so there's a spider leg there. We'll just coarse focus it. Go up in power one time. And then let's fine focus it here. All right. Any questions about any of that? I didn't use oil, so we can put it away directly. I don't need to clean the lens there. And then practice the microscopy. We already talked about that. Sorry. Practice naming the microscopes by going to this link here. Well, I'm not sure why that went on my computer because that's supposed to be a web page. All right, so be careful when you're clicking things here because you click something over here, maybe even some things there, you'll download something you don't want. You could try and buy something also, maybe. I don't know. I've never really clicked on anything. But press here to get this labeling game to work. Oh, where's press play? There it is there. I'm sorry. Press there. And then it's asking you the resolving nose piece. If you get the wrong answer, it will not be green. If you get the correct answer, it will be green. That's green, so that was the correct answer. And now it gives you another question. Tell me where the fine adjustment knob is. On this microscope, it's there, but I want to show you what happens if you get the wrong answer. It'll go bunk. You do it a third time, it'll show you purple or red. Let's go again. So red because we did it 3 times incorrect. So I gave you what the correct answer was by purple. And then let's go to adjustment knob. Also get it wrong. We'll only get one wrong this time. And let's say that one is obviously the adjustment knob. It's right there. And it's yellow because we got one wrong answer there. So the different colors tell you how many times you failed. Red means you badly failed. Yellow means you failed one time. And I don't remember what the 2 failed is, but anyways, stage clips right here or there. No, that's the stage. So this one here, green. That tells you how to do it, the power switch. Looks like there's only one on this one, so I'm going to. All right. It's a fun game. Let's come back to the worksheet and then fill in the blanks with the correct answers. When focusing a specimen, you should always start with which objective lens. When using the low power, high power, and oil objectives, meaning those lenses, only which focus adjustment knob should be used. 4C, the type of microscope used in the lab is the, and it takes two names. Don't tell me a manufacturer of the microscope, meaning Nikon microscope, because that'll be wrong. It takes two names. So that's someplace in the lab module. And then 4D, you should carry the microscope by holding on to what part with one hand and supporting the other what part of the microscope with the other hand. 4E, objectives are attached to this part of the microscope, which can be rotated to click different objective lenses into place. So name that part of the microscope here. And if a microscope had an ocular lens of 10x and a high power objective of 45x, what would be the microscope's total magnification? So write that there. When the stage is moved left, the image moved through the oculars moves in which direction? When the stage is moved forward, the image viewed through the oculars moves in which direction? Which objective lens provides the largest FOV, which is field of view? And then 4I, which objective lens has the smallest field of view, or FOV? 4J, of the methods for light adjustment, which is the most important on the microscope? And there's really two answers that I consider most important. As long as you get one of those two, it'll be correct. The lab does say one is more important than the other, but they're both important. All right, 4K, how large is the field of view when using the high power objective lens? Answer must be in millimeters or micrometers. Remember, the high power is not the highest power objective lens. And then 4L, how many hairs are in the animal slide when viewing the spider leg under the 100x objective lens without moving the slide from side to side? So you're looking at it with the 100x lens, how many hairs are in the spider leg under the objective lens? And then 2, a typical bacteria cell is 2 micrometers in diameter. In the circle below, which represents the field of view of the microscope, when viewed with the oil immersion objective, state how many cells can fit across the circle under the oil immersion lens. You must show your calculations for full credit. Any question about anything? If not, I'll be here at 8 o'clock or until the last student leaves the lab to help you answer the questions. And some of you could use some help with the question. Either you don't understand the question, or you're confused about the question, or you just need a little help. And I'm here to help you. All right. Go ahead and get started on the microscope. And I will be here until the last student leaves, till 8 o'clock.